Hi, my name's Tom Barclay, and I'm a research scientist at NASA's Ames Research Center in Silicon Valley in California. And my research deals with finding planets that remind us of home, Earth-like worlds. So one of the most basic questions we can ask is, are we alone? It's about understanding our place in the universe. And while we can't yet conclusively say whether there is life out there, there are 100 billion stars to look at. We're going to try and find if just one of them is host to life. So one of the questions on the path to answering are we alone is, are there planets out there that remind us of home? NASA built the Kepler mission to determine the frequency of Earth-like planets orbiting other stars in our galaxy. It was just 20 years ago, in 1995, that the first planet orbiting another star was detected. And in just 20 years, we've gone from knowing of 8 or 9 planets to knowing over 1,000. Make no mistake, we're living in a golden age of discovery right now. And our understanding of how we position ourselves, how we position Earth, is changing rapidly. We know of planets that orbit double stars, things that were just science fiction 20 years ago. We know of planets orbiting stars in just a few hours. And we know planets that orbit stars a tenth the size of the sun to planets that orbit stars 10 times bigger than the sun. But we want to hone in on those planets that look just like Earth. So the Kepler spacecraft spent 4 years, launched in 2009, and observed a single patch of sky. In this video, you just see the spacecraft orbiting the Earth as it did, pointing at that single patch of sky, continuously monitoring over 150,000 stars. And the reason we monitor these stars is to detect something we call a transit. We find planets using something called the transit method. What happens in the transit method is when a planet passes between us and the star, as it orbits that star, if we look at just the right angle, we see the brightness of that star decrease. And the depth of that brightness decrease coming from the star tells us how big the planet is. Secondly, because these planets are going round the star, like hula hoops, we can tell how long the year on that planet is. So if we were looking from a distant star system, looking just at the right angle and looking at Earth, we'd see one transit, one dimming, every 365 days. Knowing how often a planet goes round its star is very important because it tells us how distant it is from its star, and crucially, how much energy that planet receives from its star. And knowing how much energy the planet receives is very important. We live in a region we call the habitable zone. We want to search for habitable worlds. We want to find other planets in this habitable zone. If you're too close to your star, you don't have liquid water. You boil off liquid water. And if you're too far away from your star, you freeze out liquid water. You have a snowball world. And why do we care about liquid water? Because all life on Earth that we know of requires liquid water to survive. So when we want to find a habitable world, we look at somewhere that reminds us of Earth, because Earth is habitable. And Earth has liquid water, so we go searching for places that could host liquid water with the right atmosphere. We also care about the size of the planet, not just its temperature. If you're too big, if you're a Jupiter-like world, you have huge amounts of gas surrounding your planet. And this isn't conducive to any kind of life as we know it. Conversely, if you're a small world like Mars, you can't hold on to an atmosphere. Mars isn't inhabited, probably because it doesn't have an atmosphere, because it's too small. Earth-like worlds, Earth-like size is just right for having a rocky surface, but also being able to hold on to an atmosphere. So we know of one planet that hosts life, Earth. Earth is special. Earth has layers, it has a crust, it has a mantle, it has a core. These are things we think are important for life forming. It has plate tectonics. So this is why we're focusing on Earth. We learn as scientists not to extrapolate from one data point, but unfortunately that's all we have. And so when we're looking for places to find life outside our solar system, we extrapolate from the one data point of Earth. And so that's why earlier this year we were very excited to find Kepler 186f. This was a milestone discovery. This is the first time we found a planet similar in size to Earth, at just 10% larger, orbiting within this habitable zone of another star. Kepler 186f, shown here as an artist's conception of what it might look like if it had an Earth-like atmosphere, orbits in a star system with 4 other planets closer in. You can see the planet here bathed in orange light coming from its star that's cooler and smaller than the sun. Here I show you a top-down view. This is a movie showing here. The green region is this habitable zone I've told you about. I've said it's so important. The white and orange rings are the orbits of the other planets. Here we're just showing you something about the system this planet resides in. You see this cooler star, it's known as a red dwarf. The other 4 planets orbit all within very close to their star, so they don't enter the habitable zone, but this one planet does. It orbits its star every 130 days, and it actually exists on the cooler edge of the habitable zone. It receives about 1/3 the energy that Earth receives from the sun. So today, I was asked to talk about edges. And we're on the edge right now of determining the frequency of Earth-sized planets orbiting within the habitable zone. That's something that's just within our grasp. We're not quite there yet, but I can tell you it's looking like Earth-like planets aren't uncommon. That really, it tells us about where we are in the universe, that perhaps we aren't special, perhaps there are other places like Earth. The first planets were discovered with ground-based instruments 20 years ago, and the first transiting planets found using the same method I've described here, were first found using the Hubble Space Telescope. The Kepler spacecraft is primarily a statistical mission, and it's told us that planets are ubiquitous, planets are everywhere. But it's not actually a very good mission for following up on individual planets. Most of the planets we find with Kepler are far away, and they aren't good to study for understanding more about the planet. They tell us how common planets are. So the next generation of instruments are going to come online starting in 2017 with the Transiting Exoplanet Survey Satellite, or TESS. And because Kepler's told us that planets are everywhere, we know we can look at most stars and know there are planets orbiting that star. So with TESS, we're going to target the nearest by stars to try and find our nearest neighbors, the nearest rocky worlds to Earth. And in 2018, NASA's going to be launching the James Webb Space Telescope, NASA's next great observatory. And with this spacecraft, we're going to take the planets we find with TESS and study their atmospheres. We're going to look at the atmospheres of alien terrestrial worlds. And why should we care about atmospheres? One of the methods, probably the most likely method to detect life outside of our solar system, is using biosignatures. Now, life affects the atmosphere of our planet. It leaves telltale signs that there's life on a planet. All life affects a planet, particularly if we consider photosynthesis. The oxygen in the atmosphere is partially a result of photosynthesis. If you see a lot of oxygen, that's a signature that there could be biological life. Similarly, methane in the atmosphere is primarily there because of biology. So we go look for these telltale signs in the atmosphere, and it tells us there may be life on these other worlds. With current technology, we're only really sensitive to life we're only sensitive to atmospheres of giant worlds very close to their star. In other words, worlds that aren't habitable to life as we know it. But with the next generation of instruments, we're going to be sensitive to detecting things like oxygen and methane on alien rocky worlds. So within the next 10 years, we're going to be sensitive to these elements, and we're going to be able to potentially answer the question of, are we alone? Thank you.